Okay, so let's look at the difference between these two problems. In both, they're dependent events because the sample space changed. But however, in the second one, not only did the sample space change, the entire sample space change, but the sample space we're choosing from changed. So up here, because they're choosing two different types of bags, only the denominator changed. But here we're choosing two girls, which is kind of the same little group, so both numbers changed. Now pause this video and see if you can try the U-Try. So, U-Try A. There are 10 red, 8 white, 12 blue marbles in a bag. 2 marbles are drawn without replacement. What's the probability of drawing a red, then a blue? There are 10 out of the 30 being red, and once you pull that red marble out, there are 29 left, 12 of which are blue. So 10 out of 30 times 12 out of 29 gives you 4 out of 29. In part B, there are 8 cards numbered 1 to 8 placed in a box. 2 cards are drawn randomly without replacement. What's the probability that both cards are greater than 5? So you're looking for a 6, a 7, or an 8. So there are 3 out of the 8 cards in the first draw. Assuming that you pull a 6, 7, or 8, then you only have 2 options out of the 7 cards that remain. So that should be 2 out of 7, which would give us 3 out of 8 times 2 out of 7, or 3 out of 28%, 3 out of 28, which is 10.7%. I apologize for my key being incorrect. So 3 out of 28 or 10.7%. If you have any questions about dependent probabilities, now is the time to ask Miss Lewis. Otherwise, we're going to talk about a different type of event. It's called mutually exclusive. When you think about mutually exclusive, it's an old school term for like when you're dating, you don't date anybody else, right? Well, when we relate that to probability, it means you have nothing to do with anything else. They don't, meaning can occur at the same time. So when you're mutually exclusive, you can't date more than one person. Probability, the events can't happen at the same time. So an idea is rolling a 3 and a 4 on a number cube. You roll the number cube one time, you get one number. There's no way to get two numbers at one time. So our concept here is if they're mutually exclusive, then the probability of it happening at the same time is 0. So be careful on that because that is kind of a tricky question that'll come up. But the probability of one or the other happening is probability of A plus the probability of B. So rolling a 3 and a 4 on a number cube is 0. Rolling a 3 or a 4 is 1/6 plus 1/6, 2 out of 6, because there's 2 of those numbers out of 6, or 1/3. So anytime you see the word and, it's multiplying, except for when it's mutually exclusive, and then that's 0. Anytime you see the word or, you always add. So an example. In a specific school, you can only participate in one sport each season, which is true for some schools. Rose High is not one of those because we know some people play basketball and run track at the same time, or run track and play baseball. But here, this school only lets you do one sport at a time. So during the fall season, 28% play basketball and 24% are on the swim team. What's the probability that they play basketball and swim? Well, that's 0. Because they're not allowed to play more than one sport. What's the probability of them doing one or the other would be 52 because you would add the 28 and the 24. Alright, a number cube is rolled one time. What's the probability of getting a 2 and a 3? That's 0 because again you can only get one number with one roll on a number cube. A 2 or a 3 would be 2 out of 6, which is 1/3. Then sometimes events overlap, meaning you can have one thing happening or another, but there's some common ground in between them. And the problem with that is you cannot count that overlap more than once because it skews our data. So the definition of overlapping is events that have something in common. An example is rolling an even number or a multiple of 4 on a number cube. The even numbers on a cube are 2, 4, and 6. The multiples of 4 are just 4. So if you are asked the probability of rolling an even number or a multiple of 4, you're counting the option of 4 twice, which is changing your probability a lot, and you're not allowed to do that. So if A and B are overlapping events, we are still going to add their probabilities, but we're going to subtract that overlap, that intersection. So here's why. Let's look at this example. Suppose you have 7 index cards labeling A through G. The probability of getting the word face is the probability of getting any letter in that word. So my first bubble has the word face. Probability of getting the word cab is picking a letter from CAB, which is here. If you notice, A and C are common letters between face and cab, whereas D and G are not used in either one of those letters. So the probability of finding face or cab, there are 4 letters in face, 3 letters in cab, but if you notice, that's 100%, that's 7 out of 7, which is not possible because you have a D and a G. So 100% of getting face and cab can't happen. What we do is we subtract the overlap because this A and C are both counted twice, which gives us 5 out of 7, or 71.43%. Now let's look at some more examples. What's the probability of rolling either an even number or a multiple of 3 on a standard number cube? Well, we've already talked, an even number is 2, 4, or 6, so that's 3 out of 6. A multiple of 3 on a number cube is 3 or 6, so that's 2 out of 6. But are any of those numbers, did I say them twice? I did. I said 2, 4, and 6 for even, 3 and 6 as multiples, so you can't count that 6 again. So 3 out of 6 are even, 2 out of 6 are multiples. Subtracting the one they have in common gives us 2/3, or 66.6 repeating percent. The next one says, suppose in math class 52% of students own a dog, 33 own a cat, 14 own a cat and a dog. What's the probability of selecting a student that has a cat or a dog? So we add the 2% of individuals that have cats and dogs and subtract the intersection. So 52 plus 33 is 85, minus the 14 gives us our 71%. The next example we're not going to do because I'm not there to kind of poll the audience to see. If you'd like to do it with Miss Lewis, you're more than welcome to. We're going to move on to the You Try. Pause this video. If you have any questions, please ask Miss Lewis. Alright, so the first You Try, again, we can't do because we're not going to be able to poll the audience on strawberry and mint chocolate chip ice cream. But you can kind of do a little mini poll if you want, or we'll have Miss Lewis do it. In B, it says Xavier rolls 2 standard number cubes. What's the probability that the sum is greater than 9 or even? So you need to know the sums of a number cube because this has come up more than once. So if it helps you to list them out, you have the numbers 1 through 6 that you can get on a number cube. So this little box is going to represent what all my possible sums are. That would be 2, 3, 4, 5, 6, 7. This row is 3, 4, 5, 6, 7, 8. And if you notice, they kind of all just move over 1 until we get them all done. 10, 6, 7, 8, 9, 9, 10, 11, and 7, 8, 9, 10, 11, 12. So looking at this, the sum is greater than 9. All of these right here are greater than 9. So there's 1, 2, 3, 4, 5, 6. 6 out of 36 possibilities are greater than 9. How many of these possibilities are even? Well, that's half of them, which is 18 out of 36. And then we ask ourselves, are any of these that are greater than 9 also even? Well, these 10s and that 12 are even. So I have to subtract out that overlap of 4. So this problem is 6 out of 36 plus 18 out of 36 minus 4 out of 36, which reduces to 5 out of 9, or 55.5%. Lastly, in general, first always determine how the two events are related before you calculate your probability. Meaning, are they independent or dependent? If they are independent, life is great. You do not have to change any sample space. You just do the math. If they are dependent, you have to think about how that affects the second fraction. Does it change the numerator and the denominator, or just the denominator? Anytime you see the word and, you automatically multiply. Unless the events are mutually exclusive, meaning they cannot happen at the same time, then that probability would be 0. If you see the word or, you automatically add, unless there's some overlap, and then remember to always subtract out that overlap. If you have any questions about compound probability, now's the time to ask Miss Lewis. If not, please complete your assignment on this section.